How do you do, ladies and gentlemen, and boys and girls? I am Julius Sumner Miller, and physics is my business. And our very special business today is the subject of simple machines. Simple machines. Now, when you study these matters in school, it is usually said that these are the 6 simple machines. The lever, or as some pronounce it, the lever, the inclined plane, the wheel and axle, the screw, the wedge, and the pulley. And I wish in this program to show that really all of these reduce to only 2, the lever and the inclined plane. And what is better for us to contemplate is the following, that all of the things I will have to deal with here today are the most plebeian and simple and homely and commonplace. And my purpose is essentially this, that when you pick up your fork and knife to eat your dinner, I hope you would recognize that you are using some levers. Indeed, the sharpened blade of the knife is an inclined plane in addition to the tool itself being a lever or lever. And how about the prongs of the fork? The prongs of the fork are usually sharpened a little bit, so they are wedges, and wedges are inclined planes. So let us go at random to some of the things we have here, and you will see exactly what I mean. Consider, for example, the following. Here is a block of wood in which I have already lodged some bolts and screws and other things. Here is a screw, and I'm going to attempt to lodge it further into the wood with a tiny screwdriver. A tiny screwdriver. No success. Why? Well, let us look at what really happens. The handle of the screwdriver I have enlarged, looks like that, and I apply a force this way and a force that way, so that I turn it about a central axis, and these 2 forces, equal and oppositely directed and parallel, are said to be a couple, C-O-U-P-L-E. You see a couple of forces acting in this way. Now, the small screwdriver had too small a radius. So what do? I use a big screwdriver, and the same force will accomplish my purpose very readily, as you will see. Here is a big one. And the handle, of course, is very much bigger, so that the torque, or the turning effect of my force, is very much increased. There it is. Beautifully accomplished. Consider now, I remark that a threaded cylinder, which we call a screw, is really an inclined plane. And I hope you see the inclined planeness in this threaded shaft. I'm going to prove to you that it's an inclined plane. Here I have an inclined plane cut out of paper, and it goes uphill to my left. I'm going to wrap this around a cylinder, and I hope you see that what I will get out of it is this. Here is the cylinder, and I wrap the inclined plane around, and I get a threaded shaft, which is a screw. Now watch this. Here, I'm going to wrap it around. Let me finish it here first. And there you will see the inclined threads. Now, I have wrapped this one around so that the threads go like that, which is a left-handed screw. I have cut the other one so that when I wrap it around, it gives me, I hope, yes, let me turn it over. No, there. Notice I'm a little twisted up here. Well, notice I'm glad I'm twisted up, because this suggests that even professors of physics can get a little bewildered. I know where I made the mistake. One of these I have to turn over and use the mirror image, and then it will give me a right-handed screw. Now, this business of left-handed thread and right-handed thread, very important. Illustration. Oxygen tanks used to take care of sick people are right-handed threaded. Nitrogen tanks, on the other hand, I believe, are left-handed threaded, for the very reason that then nitrogen could not be inadvertently and accidentally fed to a patient who should be getting oxygen. See, very important idea. Let's look at another one. Here is a bottle with a screw cap, and the housewife finds that she cannot undo it because it is too firmly fixed. What does she do? Answer. Provide herself with a lever. and a notched jaw, which is essentially an inclined plane. And then she puts it on there, and ever so gently, there it is. So I say that for little bottles with small screw caps, you have a small Stilson wrench, and for medium bottles, a bigger Stilson wrench, and for very big bottles, a very big Stilson wrench. And any well-equipped household, I think, should have at least 3 Stilson wrenches. Consider, for the housewives and the boys and girls and the teachers, here is a grater. Now, what is a grater? A grater, well, a grater, you grate with a grater. There it is. And I say a grater is an inclined plane. Very clearly an inclined plane. How about a wedge? A wedge. A wedge is clearly an inclined plane. Consider the following. Here is a railroad spike. Indeed, it is pointed. Quite like nails are pointed. Why? They are inclined planes, and the advance into the railroad tie is more easily accomplished because this is an inclined plane. Let's go to an ordinary hammer. Here is a nail that I've lodged in here. A lot to say about this. Let me use the hammer as a lever. Not much success. I improve its mechanical advantage by providing a block under the head, and there. And now what must I say? What must I say? Very important. What do I feel when I feel this nail? Very hot. Friction develops heat, and friction is a dissipative force, always arising when work is done, and about which we spend fortunes to eliminate. Very important. But remember, if we could accomplish the elimination of friction, no motion whatsoever would be possible. A very terrible thing to contemplate.